Hi everyone, I am Pragati from ECE BIT. So topic for today is basic searching tactics, an overview of fundamental searching methods in data structures. Coming to the introduction part, what do you mean by searching? Searching is one of the most fundamental operations in computer science. It refers to the process of finding a specific element like target or key in a data structure like arrays, linked list, trees. Why is searching important? If we know the definition of something, let's discuss about the importance of it. Why is searching important? Searching is used in almost every real world applications of data processing, like finding a name in a contact list, looking up a word in dictionary app, searching a product in an e-commerce database, locating records in database or memory. Efficient searching is key to improving application performance, especially when working in large data sets. Next, discussing about the types of searching in data structures. There are huge number of techniques in which we have listed a few here, that is linear search, which is also known as sequential search, binary search, jump search, interpolation search, exponential search, Fibonacci search, hashing, hash table lookup, search in linked list. First, let us discuss about linear search. As we see in the pic, we are linearly picking something. That is meant by linear search. Now, let us understand about the concept and methodology behind linear search. Linear search is the simplest searching technique where each element is checked sequentially until the desired element is found or all elements have been checked. It is straightforward and does not require the data to be sorted. Without sorting the data, this method helps us in locating or searching a required key element. Next, let us understand how it works. Here, as shown in the picture, we have to find a key element or a target as 87, which is located in the index number 6. This method of linear searching, it goes from the index 0, that is which has a element of 21, and index 1 has 22, index 2 has 34, and it continues. Like that, at the linear search method, it compares the value, that is key element 87, with the index containing a value, that is 21, 22, 34, etc. It compares the target element to that. Then as soon as it finds the key element, that is target element, which is found here in the index 6, it returns that value. So, it starts from the first element, compare the target with each element. If a match is found, it returns that index. If it is not found, then it returns -1 or indicate it is not found. Next, here is a small program explanation or example of linear search where it is initializing with a keyword linear search. It's int array, int size, int target. Then we are using a for loop over here, initializing I with the 0, then and it should be less than size, and it is increasing plus. Then again we are using a if statement, that is if the choosing element is equals to the target, then it returns that value, or else it returns -1. Next, let us discuss about binary search, the second type. Without going or before going to the actual meaning of binary search, let us know what all the prerequisites for binary search. Binary search requires that the data set to be sorted prior to the execution of the search algorithm. This means that whether it is an array or list, the elements must be arranged in a defined order, either ascending or descending, to enable effective searching. Next, let us know in depth of binary search. The first step is the binary search algorithm operates by dividing the dataset into halves repeatedly. It starts by comparing the target value to the middle of the element of the array. If the target is equal to the middle element, the search is complete. If the target is less than the middle element, the search continues in the left half. If greater, it proceeds to the right half, continuing this process recursively. This is the actual framework of binary search. Next, we are going to in-depth discussion of binary search code, where here we are initializing with a keyword and binary search with int as a data type, then int array, int size, and int target, same as linear search code. Then here is a small difference. Here we are initializing the keyword left as 0 and right should be size less than 1. Then we are giving the loop while when it is left less than or equal to right, then int mid will be equal to left plus right minus left by 2. If array of mid is equals to target, that is middle element is equals to target, then it returns mid. If it is less than target, then left element will be the increase of 1 of mid, or else it should be right, that is the right element should be equals to mid minus 1. If all this condition is false, then it returns minus 1. This ends the program. Now let us know the time complexity comparison with linear search. Binary search is significantly more efficient than linear search, since it doesn't need to search from the first index and go till we find the target element. It doesn't need to wait till for that. Whereas especially with large data sets, while linear search operates with a time complexity of 0 of n, binary search achieves a time complexity of 0 of log n, showcasing its effectiveness in quickly narrowing down the search range. Searching in advanced structures. There are few examples like searching in trees, searching in graphs, etc. Here let us see about searching in trees, that is binary search tree. In data structures such as binary search tree, searching for a node involves comparing the target value to the root node. If the target is less, the search continues in the left subtree. If more, it moves to the right subtree, ensuring efficient searching with a time complexity of 0 of h, where h is the height of the tree. Next, we are gonna see about hash table and their search efficiency. Hash table uses a hash function to map keys to specific locations in an array, allowing for average case constant time complexity of 1 for lookups. Understanding collision resolution techniques such as chaining or open addressing is essential for maintaining efficiency in real world. Again, one more example, searching in graphs. Searching in graphs can be performed using algorithms such as DFS and BFS, that is depth first search and breadth first search. These methods explore nodes in a systematic way, with DFS going deep into the graph structure and BFS exploring all neighbors at the present depth prior to moving on, which proves vital in pathfinding applications. That is, in DFS, it goes to the depth node till it finds the last element, that is last left subtree or last left right subtree. Whereas in breadth first search, it doesn't go straight to the depth, whereas in other way it search for the element which is in the neighborhood of that element. So that's the difference between DFS and BFS. Optimizing search techniques. Techniques for improving search items, that is search times. That is, if we have to search for a particular element, which all the types of search methods we need to figure it out. That's the main task. Optimizing search algorithms can be achieved through methods like indexing, catching frequently accessed data, and employing better data structures designed for such efficiency. These optimizations can greatly reduce response times in applications that rely heavily on quick data retrieval. Now let us know about the real-world applications of searching methods using data structures in C. That is contact management systems, database indexing, e-commerce product search, game pathfinding using AI file search systems, hospital managed systems, etc. So concluding my topic, in summary, the choice of searching techniques significantly impacts application performance and efficiency. By understanding the strengths and weaknesses of each method, developers can make informed decisions that enhance data retrieval process within their applications. By concluding this, I am gonna end my topic. Thank you all.